Alright guys, today's goal. Bad habit of mine. The learner will, I forget to switch to pen. The learner will understand solving inequalities in one variable. So quick review. Use limits to state the end behavior of the function. Okay, so A is positive, so this means the limit as x approaches negative infinity of f of x is negative infinity. The limit as x approaches positive infinity of f of x is positive infinity. Here, the limit as x approaches positive or negative infinity is negative infinity. Combine the fractions to reduce your answer to lowest terms. So turn that one into a fraction. Common denominator, x squared. So you got to multiply by x squared over x squared. So I get 2 over x squared plus x to the third over x squared, which is 2 plus x to the third over x squared. I don't think we can simplify anything. Put this over 1. Common denominator here is x. So you got to multiply by x over x. So I get x to the third plus 1 over x. And I think that's it. We'll see. Maybe I made some mistakes. Because I think I can separate x to the third plus 1 into... But I don't know if they need it factored or not, so we'll see. List all the possible rational zeros and factor completely. I typed factor wrong there. So all the possibles. Plus or minus 4, plus or minus 2, plus or minus 1. Because remember you do negative 4 divided by 1. And all the factors of it. Okay. And then find one of them that is. So check it in your graph. So negative 2 is one of them, so I'm going to use that. Remember synthetic division. And then I have x squared minus x minus 2. So, and then that would factor into x minus 2, x plus 1. And I also have x plus 2. So there we go. Let's see if we did them all right. We did. So what we're going to learn about: polynomial inequalities, rational inequalities, others, inequalities, and applications. And why designing containers as well as other types of applications often require that an inequality be solved. Alright, polynomial inequality takes the form f of x is greater than 0, f of x is greater than or equal to 0, f of x is less than 0, f of x is less than or equal to 0, or f of x cannot equal 0, where f of x is a polynomial. To solve for f of x greater than 0 is to find the values that make f of x positive. To solve for f of x less than 0, you find all the values that make f of x negative. Let f of x equal x plus the quantity x plus 3 times the quantity x minus 4 squared. Determine the real number values of that cause f of x to be a 0 to be a positive, and to be a negative. Okay, so the zeros we would know. X plus 3 equals 0. X minus 4 squared equals 0, so you get x equals negative 3. Square root it. X equals 4. So there's our two zeros. So let's take a look at this graph. And you can put it into your calculator just like you see it right now. And it looks, if I sketch this, it looks like this. But that's actually touching. So here's A. Negative 3, positive 4. B. F of x is negative when x is less than negative 3. Oh, that's C. So let me fix that. Now B. B is tough because you got to go negative 3 is less than x and x is less than 4. And then, because 0 is not positive. Maybe they count as positive, we'll see. But 0 is not a value. So we look at it that way. Or you could have done interval notation if you wanted. So like reminder of interval notation here. Let's see. There's the reminder of interval notation. Let's see if we're right. Nope, the biggest thing we missed was we should have written it like this. And we got to remember the union. But yeah, we had the right things. So we didn't say multiplicity of 2, but not a big deal. Alright, so solving this graphically. So first thing we got to do is get it less than or equal to 0. So subtract 2, add 8. Subtract 2, add 8. So I get x to the third minus 6x squared plus 8x minus 2 less than or equal to 0. So go ahead and graph it on your calculator. Find the zeros. So graph x to the third minus 6x squared plus 8x minus 2. And then there's 3 zeros there, so we gotta find them all. So go ahead and find them. And if you found them, you should have gotten the 3 zeros are x equals 0.32, 1.46, and 4.21. So it was like that. And they want to know where it's less than or equal to 0. So let's do interval notation, because we have it less than or equal to 0. So if you look here, starting at the first 0 and below, so I go negative infinity to 0.32, but this time it can equal it because it's less than or equal to 0, union. The other range where is between the two zeros. So I go 1.46 to 4.21. Let's see if they chose to do the same way. They got it equal to 0, graphed it. Yep. So there we go. Alright. Determine the values of x that can cause r of x, the function, to be a 0, to be undefined, positive, and negative. Okay? So the 0. Well, set it equal to 0 and solve it. And you would get, so here's a. 0 equals x plus 1 divided by x plus 3, x minus 1. Multiply by the denominator, so you get 0 equals x plus 1, so x equals negative 1. So there's the 0. Second part be undefined. Well, when x equals negative 3 or 1. So now we need to look at the positives and the negatives. So if I did a quick look at my graph and it's like this. Not quite like that. Hold on a sec. Because what was our 0 again? It was negative 1. And then like this. Okay? So see the intervals in which it's positive. Well, let's see. From, where's the vertical asymptote here? Isn't that x equals negative 3? So for C, I go from negative 3 to 1, or negative 1. And then union this other vertical asymptote was at x equals 1, so it would be 1 to infinity. And then D, where is it negative? Well, negative infinity to negative 3, union, what was the 0 again? Negative 1 to 1. So let's see. Are we got the 0, undefined at negative 3 and 1. Negative 3, negative 1, and then 1 to infinity. Yep, looks like we did it right. If you're not sure, guys, ask me about this one tomorrow. Have me do it in class as well, okay? Alright, solve the inequality. Well, let's see here. Alright, well, if we did it this way first, divide both sides by x minus 2, you get square root of x plus 1 less than or equals to 0. Square both sides. You get x plus 1 less than or equals to 0 when x is less than or equal to negative 1. But can we have it be less than or equal to negative 1? That's where it would be negative, but can you take the square root of a negative? No, but we know that's also a 0, so that's good. The other 0, well, you could have, actually they're factors, so we could have just also said x minus 2 equals 0, so x equals 2. Okay? So let's take a look at the graph to see where it goes between negative 1 and 2. Because we know we have to be greater than or equal to negative 1 at least. So oh, we want to stay less than or equal to 0 though. So where would they all be negative? That's what we got to look at. That's what we got to look at. And if you see the graph, it does this. And that's the other 0. What's the other 0? 2. So the only place where it's less than or equal to 0 are when it's from -1 to 2. And there we go. Okay? Again, if you have some questions, ask me in class, please. Let's get ready to roll.